Yes, sir.
If any okay, any difficulty, please let me know. Okay. Now this is the previous class problem. We because we don't have the time at the time, so we stopped here. A shaft is made of mild steel is required to transmit the 100 kilowatts of power. Okay, power is given and speed is given RPM and the supported the length of the shaft is total length of the shaft is 3 meters is given and it is carrying the two pulleys at each weight is 1500 newtons. So I have shown in the figure 1500 1500 two pulleys here, and these two pulleys are supported at a distance of 1 meter from each end. It means from this end 1 meter, from this end it is 1 meter. Okay, so such kind of diagram also you need to represent in the examination. Whatever the given data is given, what is the parameters is given in the question, read that properly and draw the diagram. Okay, for especially for this design of shaft, diagrams are most important. If you forget to drawing the diagram, so some marks will be deducted, means like 2 marks or 2.5 marks, some marks will be given to the diagram also. Okay, don't forget to draw the diagram. If you read the properly question, so you can easily draw the diagram. Okay, and here the question itself given your choice as a selecting the stresses. Okay, and determine the diameter of the shaft. Now see the diagram. The diagram is subject into the combination of torsion and bending. Because of the pulleys are mounted on the shaft is going to bend, and because power is transmitting to the power through the shaft, so it is subjecting to the torque. Okay, so because of this we are concluding first analysis of the problem is important, as I said in earlier classes. What first identification of the problem, what identification, this problem belongs to which category. So how many category we have? Total 6 categories. 4 in a strength point of view, 2 in a rigidity point of view. Total 6 categories are there. Among the 6 categories, the given question belongs to which one? That is the first question. If you identify this, which category this one, easily we can take the formulas. I think there is no getting difficult to write this formula. Is there any difficulty? Only one line is there. 1 by 2 m plus square root of m square plus t square. This much of equation is there. So I think there is no difficulty to write this equation. But before writing this equation, we have to analyze whether this equation is suitable for this question or not. Okay, so we identified based on the there is a one torque is there is a one bending moment is there, so we are concluding like this. This is the problem belongs to combination of torque and bending moment. So because of conclusion we selected this equation. That is according to the maximum principal stress theory, equivalent bending moment ME, equivalent bending moment ME equal 1 by 2 square root 1 by 2 m plus square root of m square plus t square. Okay, this ME represents this equation. Okay, pi by 32 into sigma b into dq. In this equation we need to calculate this d value that is asked in the question. What is the design of shaft, means determine the diameter of the shaft. Okay, here in question given, assume the safe values of the stresses. So safe value for the bending stress we considered for the steel material. Here mild steel is given, the shaft material is given mild steel. So for that reason, based on the material property, I selected sigma b as a 100 megapascal. Okay. Now what are the parameters required to solve this equation? Torque we required. Okay. Bending moment, maximum bending moment we required. Okay. And D is the question mark that is asked in the question. Now to calculate the torque, generally you know the power equation, P is equal to 2 by 60. Through this relation you calculated the torque. Now tell me the answer here. Power is given in terms of 100 kilowatts, that I am converting into watts, and into 60 by 2 pi n. Speed is given 300 rpm, so I wrote here 300. Now tell me the t value. How much
3183.
you 3183? Okay, solved in the last class. 3183. What is the units? Units.
Megapascal.
Not megapascal. We calculating the torque. We calculating the torque. Torque units is a general Newton meter. Why I am directly writing the Newton meter? Because see the units of power. What is the units of power here? Kilowatts. That kilowatts I am writing in terms of watts. Watts means joules per second. Watts means what? Joules per second. Or else we can write joules per second, Newton meter per second. Joules means Newton meter per second. I am writing directly. It means Newton meter represents the torque. That is I am writing directly here. When you want to convert it, after getting the answer Newton meter, convert in Newton mm. Okay. Now we calculated the torque. Now leave it. Now what we required? Maximum bending moment. So maximum bending moment is you go through that whatever the you calculate you studied in the strength of material. There are so many relations are there. Bending moment relation W into L, WL by 4, WL square by 8. Okay. So many relations are there. You go through that one, recall all relation whatever you have. Okay. Because all relations are going to use in the design of shaft. Now see here, maximum bending moment is load into perpendicular distance. So total load how much here? Total load is on the shaft is 3000 newtons because this first pulley having the 1500 newtons, second pulley having the 1500 newtons. So here question is given, it is carrying the two pulleys, each of weight is 1500 total 300. Now what is the supports? What is the reaction at the supports here? Suppose this is the A point, this is the A point reaction at A, and this is the reaction at B point. So what are the reactions here? Total loads are going to be distributed on the this one. Okay. So because this is the symmetrical section. Why I am telling the symmetrical section? Because these two pulleys are mounting at a same distance. From this end 1 meter, from this end it is 1 meter. It is having the 1500. It is also having the 1500. So that reason it is a symmetrical section. Okay. So because the symmetrical section total reaction at A is a 1500, total load is equally distributed 1500, and here total load is distributed as a 1500 means reaction at A 1500, reaction at A at B 1500. Okay. Now what is the bending moment here? Bending moment is maximum bending moment we can find in this diagram is 1500 into 1. Otherwise 1500 into 1. We can select from this side, we can select from this side because it is a symmetrical one. Okay. So maximum bending moment is 1500 into 1. So 1500 into 1, that is the 1500 into 1. Okay. So 1500 we'll get the answer. What is the units here? Units is 1500 Newton meter because the distance here 1500 it is meter. Okay. So we got the bending moment, maximum bending moment, and as well as we got the torque value. Now tell me the answer of diameter D because I have written everything here. Only you need to submit the values in this equation. So M value we got as a 1500 Newton meter, 1500 Newton meter. Here 3183 Newton meter, and sigma B we calculated, we assumed as a 100 megapascal. Okay. Tell me the answer. Tell me the answer. D value in terms of mm. It means first you got the D value in terms of meter. First you will get the answer in terms of meter. That convert it into mm. After converting, tell me the answer of D. Tell me the answer of D. It means first you calculate separately this one. First you calculate separately this one. Okay. After calculating, convert this total product into Newton mm. First calculate the me value 1 by 2 m plus square root of m square plus t square. First calculate this one. You will get the answer in terms of Newton meter. That convert it into Newton mm. Okay. Because here sigma b is the Newton per mm square. Sigma b is the Newton per mm square. If you calculate directly Newton meter and equate into this equation, you will get the wrong answer. Calculate separately this product in terms of Newton mm, means after calculating you will get the answer Newton meter, that convert into Newton mm. After converting the Newton mm, equate to this equation, then you will get the answer mm. Okay, make it fast. You are taking so much time. Simple application is there. Make it fast. Everything I wrote on the screen. Only you need to substitute the values. This is a D value. Make it fast. What is the D value? First write the whatever the product you got, you get the answer in terms of Newton meter, convert it into Newton mm, Newton mm, then equate to this equation. Tell me the value D. Why are you people taking so much time? I'm writing here 70 mm. Oh no, sorry, not 70 mm. 63.46. Okay. 63.46. 46 mm. Is it mm or meters? Rule number 108 given. 108, is it in mm or a meter?
Sir.
Okay. Rule number 002 got the 66.18. Now, see, I calculated according to the first theory, maximum principal stress theory. I am giving the question to you. Calculate this problem according to the maximum principal shear stress theory. Maximum principal shear stress theory. According to that, you need to calculate. I am writing the equation here. You do after completion of the class and tell me the next class. Okay?
So
Equivalent
can you
torque
explain
T.
this? One
Which
second, sir.
one?
Starting this
This
problem,
problem,
sir.
huh?
Yes, sir.
Okay,
From
okay.
starting.
Okay. So same, the question is given here. A shaft is made of mild steel. Okay. Remember the type material type here, mild steel, required to transmit the power. This much is given. Power P is equal to 100 kilowatts and running at a speed of N is equal to 300 RPM. Okay. The shaft is supported. Whatever the shaft is there, total shaft length is given here 3 meters. So that I have written in the diagram 3 meters. Okay, it carries the two pulleys. Okay, it carries the two pulleys, each of weight 1500. Okay, each pulley having the 1500. How it is locating? It is locating supported at a distance of 1 meter, 1 meter from the ends respectively. It means the position of these pulleys are 1 meter from this end, 1 meter from this end. Okay, question itself given assuming the safe values of stresses, means it is given to you to assume the whatever the values are there for this system. So based on the material type, as I said, remember, okay, as I said, to remember, that is metal type is mildly steel is given. So for this type of material, sigma B I am considering as a 100 megapascal. Okay, and determine the diameter of the shaft. So first, before starting the solving the problem, we need to conclude, we need to analyze the given question belongs to which category. In design of shaft, 6 categories are there. As I explained in earlier, whatever the theory classes, there are 6 categories are there. So in that 6 categories, this given question is belongs to which one. So based on, because it is power transmitting the power, so because of that reason the shaft is subjecting to torque, and because of the mountings of the two pulleys here, the shaft is going to subject to bending moment. Okay, so because of these two reasons we can conclude the shaft is, whatever the system is given in the question, that is subjecting to the combination of the torque and bending moment. Okay, like that we identified. So after identification, we need to select the formulas. So we selected the first formula: equivalent bending moment equal 1 by 2 square plus m plus square root of m square plus t square. This me represents, this me represents the this one. Okay, you selected the total equation. Now what are the things you required? M value you required, T value you required. Because one here, how many unknown parameters are there? D unknown, T unknown, M unknown. In equation, if more than one unknown is present, we can't solve the problem, isn't it? So here 3 unknowns are there, M, M, T, and this is the question is given to calculate the D value. So T value we can calculate from the power equation, P is equal to 2 pi NT by 60. Okay, this T value we can get from this relation. So that is T equal P into 60 by 2 pi N. So that is converted like this. P is given here 100 kilowatts. That kilo I am converting into directly watts. It means multiplying with the 10 cube. Okay, into 60 by 2 pi N. N is speed is given 300 rpm. That is I am writing here. After substituting the all values, you will get the 3183 Newton meter. Okay. Now bending moment, maximum bending moment. So see here, observe the figure. Maximum bending moment is, because it is the system is given in the question, that is total symmetrical one. Symmetrical one means here how much it is having the length and how much the weight is there. Same you can find this side also. So it means if you calculate the bending moment, same will apply here also. Okay, so that reason I am calculating only one side, that is the 1500 into 1. Bending moment equation is there. What is the bending moment equation? W into L. Okay, so why I am writing the W into L? Because so this is appearing as one cantilever, because this is a symmetrical one. Okay, so cantilever means the load into perpendicular distance. Okay, so load into perpendicular distance I have written, that is 1500 Newton meter. So two values I am substituting in this equation, and first after substituting the values, you will get the answer, this product in terms of Newton meter, that you need to convert into Newton mm, because sigma B is a megapascal, that means Newton per mm square. So if you get the directly, if you substitute the Newton meter value to this Newton mm square, you will get the wrong answer. Okay, keep in this mind that whatever the Newton meter you getting the directly from the getting the answer, that you need to convert into Newton mm. After converting, you need to equate to this equation. After equating, you will get the D value. Okay, so this is the procedure. Now I'm giving the question to you all people. Calculate the same answer according to the second theory, that is equivalent torque TE equal square root of m square plus t square, m square plus t square. Okay, what is TE? TE is nothing but pi by 16. T is nothing but pi by 16 sigma s into d cube, into d cube. So this d cube only we need to calculate, that is given in the question, that is asking to calculate, design the shaft, calculate the diameter of the shaft. Now sigma is what? Sigma is not given in the question, that is given to your choice. Select the proper value of stresses, safe stress values. Okay, so when it is statement like given, So first go through the material. What type of material is given? Mild steel is given in the question. So according to mild steel, sigma S permissible shear stress value for this is 60 megapascal. Remember these values. Okay, 60 megapascal, nothing but Newton per mm square. Okay, already we calculated m value, already we calculated t value. Substitute this one, you will get the answer in terms of Newton meter. After getting the Newton meter answer, you need to convert into Newton mm. Newton mm. After converting this one, substitute the equate to this equation. Then you will get the answer in terms of d value mm. Okay, you calculate it and tell me next class. Though any doubts regarding this problem, otherwise I will go to the next problem. Shall I go to next problem? Nobody is responding.
Yes, sir.
Now see here, a line shaft is, one line shaft is there. Line shaft means continuous shaft. Okay, so I'm drawing the diagram. For each question you need to draw the diagram in exam. Don't forget to draw the diagrams. Okay, so the one line shaft is there, continuous line shaft, and it is driven by means of motor placed vertically below it. So it is, this shaft is driven with the help of electric motor that is placed below this shaft. Okay, that is below this shaft. Here one electric motor is there, and directly just drawing the one block diagram for the motor. Okay, this is the motor that is placed vertically below this shaft. Okay, how it is transmitting? To transmit the power from the motor to shaft, we require the pulley. We require the pulley. That pulley I'm drawing here. Okay, this is the pulley. The pulley here given question. The pulley on the line shaft is 1.5 meters in diameter. The pulley diameter is given here 1.5 meter. The pulley diameter is given in the question 1.5 meter. Okay, diameter. The belt tension 5.4 kilonewton and 1.8 kilonewtons. It means what type of system is given here? Here power transmission system by the belt drives. So this topic you have already studied in the theory of machines. For the A section people, I thought the subject belt transmission system. Okay, so belt drive having the tension here 5.4 and 1.8. It means I will show the diagram as from the front view. Okay, from the front view, this is the pulley. Okay, is having the tension. It is having the tension like this. Okay, it is having the tension like this. So I'm showing the downwards because the whatever the pulley is attached to the motor vertically downwards like this through the belt drive. Okay. Okay, so this is the T1, this is the T2. So T1 represents the 5.4, T1 represents the 5.4 kilonewtons. Why I'm writing the 5.4 for T1? Because tight side having the maximum tension. Remember this one, tight side of the belt having the maximum tension, and slack side is having the less tension compared to the T1. Okay, 5.4 kilonewtons, 1.8 kilonewtons. Tight side here given in tight side and slack side. Okay, of the belt drive respectively. Both these tensions may be assumed to be vertical. So I have written here, drawn the vertically only. If the pulley be overhang from the shaft, if the pulley overhang from the shaft, okay, here I have drawn like that only, shaft. Distance of the center line of the pulley from the center line of the bearing is 400 mm given. Okay, so the distance between the bearing and pulley is given. Here I am writing the bearing diagram. So this is the conventional representation of the bearing. In examination also, whenever the bearings is given, you need to draw like this only. Okay, bearings means draw the square box and show the cross marks in that one. Okay, 400 mm. Question is asking find the diameter of the shaft. So this is the center distance of the pulley and shaft is 400 mm. 400 mm. So like this, you need to draw the diagram in examination also with the pencil, with neat sketch. You need to show that all dimensions. Okay. For this also you have the marks. Now question is asking to calculate the diameter. What is the diameter of this shaft? What is the diameter of the shaft D? So that is the question but that we are discussing in this unit. That is the design of shaft. Design of shaft nothing but determining the safe dimensions for the shaft based on the considering the different parameters. Okay. Now to calculate this D, first we need to identify the problem. I am repeating for every problem. Don't forget this one. Identification of the problem is very important. The question is given. This question belongs to which category? This question is belongs to which category? So tell me what type of category this is the one? Anybody? Nobody responding. See here, this is the problem belongs to combination of torque and bending moment. Why I am telling the torque and bending moment? See, this motor is attaching to this pulley. Whenever the motor is start rotates, the pulley also going to rotates. Now nothing but torque. The shaft is going to start rotates. That is the subject into torque. And because pulley is mounting at one end of the shaft, there is a chance of bending of the shaft. There is a chance of bending of the shaft. Okay, it is nothing but maximum bending moment and maximum torque. So T and M are appearing in this diagram. T and M's are appearing in the diagram. It means this is the problem belongs to combination of torque and bending moment. Okay, we identified. Okay, now the question is which equation we need to apply here. For the combination of bending moment and torque, we have one is maximum principal according to the maximum principal stress theory, another is according to the maximum principal shear. Among these two, between these two equations, which equation is suitable for this question? Which equation is suitable for this question? See the data. Assuming the maximum allowable shear stress. Assuming the maximum allowable shear stress. So based on this statement, the second theory we can use here. What is the second theory? Equivalent torque TE equal square root of M square plus T square. M square plus T square. Again TE means what here? TE I am writing here. TE means what? Pi by 16. TE means what? Pi by 16 into sigma S into dq. Okay, dq. So sigma S, why I selected this equation instead of the previous another maximum principal stress theory? Because the question itself given shear stress theory. Question shear allowable shear stress value given. This value is given, so that reason I am taking this equation. Okay. Now question is asking D value. Now to calculate D value, what are the additional parameters you required? M value you required and T value you required. Okay. So T value first we are going to calculate it. T is the nothing but torque. So torque in previous problem how we calculated power through the power relation. Power relation P is equal to 2 pi NT by 60. We were used this equation to calculate the torque. P is equal to 2 pi NT by 60. By using this relation we calculated. Now check whether this equation is suitable for this type of problem now at this situation. To calculate the torque from this equation we need speed, we require the speed, and additionally we require the power value, because to calculate this T value, speed we required, power we required. If we don't know these two values, this equation is not suitable for this kind of situation. See, power is given in the question. In the theory, whatever the question is given, there is no power. So that reason this equation is not suitable for this type of problem. Then how we can calculate the torque? Already I explained in the part, whatever the slides I shared you. If the system is given according to the belt drive system, power transmission system through the belt drive, at that time torque we can calculate as T1 minus T2, T1 minus T2 into radius of the pulley, T1 minus T2 into radius of the pulley. Through this relation also we can calculate the torque value. When we have to select this equation, we have to select when the T1, T2 presence in the problem, then only we need to select this problem. We select this equation. Okay. When we have to use this equation, when the question containing the power value and speed value, then only we need to select this equation. Okay, because the question is given T1, T2. Here T1, T2 is given in the question as a 5.4 and 1.8. Okay, so that's the reason I'm selecting this equation. T1 as a tight set, T2 as a slack set, R is the radius of the pulley. So radius of the pulley, what is the radius of pulley here? Diameter is given 1.5 meters. Diameter is given 1.5 meters. 1.5 15 means 75. 7.5 it means 0.75 meters. R value is 0.75 meters. 0.75 meters. Substitute the T1, T2 here. That is, you need to substitute that in terms of kilowatt. Don't substitute the directly. Substitute the T1, T2 in terms of kilos. Kilos means T1 5.4. 5.4 means 5.4 into 10 power 3. 1.82 10 power 3. Like that you need to substitute. Don't substitute the as it is value 5.4 like that. 5.4 into 10 cube means 5400. 5400. 1.8 means kilonewtons. I am converting into newtons. 1.8 means 1800. 1800 into 0.75 into 0.75. So what is the answer? Tell me the answer in terms of Newton meter, because we are substituting the here 0.75 meter. Okay, Newton meter. What is the answer? T value? Make it fast. Whenever you are coming to the DME class, don't forget to take the calcs. Without calc, you can't complete this subject. Calc and formulas are very important. You must remember the formulas. You must take the calc along with when you are sitting to the class. What is the T value? Simple thing. 2700 I am writing here. 2700 Newton meter. Now bending moment. See, observe the diagram. For the bending moment, I am taking the equation, maximum bending moment equation. So just see the screen. I have written the answer here. Just see the screen. It is appearing as a cantilever beam. It is supported in the. Yes, please mute yourself.
Yeah, hi.
Okay, see here. Observe the diagram. This diagram is appearing as a simply supported beam. Why I am telling the simply supported beam? The shaft is inserted in the bearing. Okay, and at one end it is attaching to the pulley. Okay, pulley is nothing but it is subjecting to the point load here. Okay, point load, and the distance from this pulley to the distance from the fixed support is fixed one is 400 mm. Okay, so it means this is the load into perpendicular distance, that is the bending moment. Load into perpendicular distance, W into L. For cantilever beam, What is the bending moment equation? W into L. Again, what is the W here? What is the W here? The question. W is given. See the question. Load is not given. Observe. See, read the question. In total entire question, there is no appearance of the load. So we need to calculate load again. What is the load here? Whatever the tension in the tight set and slack set, that is represents the load. It means if you add the T1 plus T2, that represents the load here. That represents the load. Okay. If you add the load T1 plus T2, we will get the load value, means 5400 plus 1800, that is the load. How much you will get W value if you add 54 1.8? It means 6 8 is a 12. It means total 12 and 7. So total 72. 7.2. It means 7.2 means 7200. 7200 newtons. Okay. Now right here 7200. 7200. What is the length? What is the length here? 400 mm. So this 400 mm here, convert this mm into meters, because we got the answer T value in terms of meter. We got the answer T value meters. So that's the reason convert this 400 mm into meters. Otherwise, sir, why we do like that? We converting this torque into Newton mm, then we are directly taking the 400 Newton mm. Your wish. But the thing is, all parameters having the same units. Okay, you can convert this in Newton meter into mm. Otherwise, you can convert this 400 mm into meters. Okay, so 400 meters I'm converting here. 400. It means what is the here? 0.4 meter. 0.4 meters. So what is the answer? Tell me the answer. 7200. 2880.
Sir.
Oh, you are getting, you're telling directly substituting the value mm. 2880, that is Newton. Okay, meters. Newton meter. Newton meter. Okay. Substitute this T value and this M value in the above equation. First substitute the T value and M value in this equation. Get the answer in terms of, after substituting you will get the answer in terms of Newton meter. Okay. That convert into Newton mm. That convert it into Newton mm. Why? Because the reason is sigma AC is in terms of Newton per mm square. So that is the reason. First, after getting the answer, after substituting, you will get the answer in terms of Newton meter. Convert that into Newton mm. After converting, equate to this equation 5/16 into sigma s into d cube. Okay. After equating, you will get the answer D value directly in terms of mm. Okay. You will get the answer D in terms of mm. Tell me the D value now. Tell me the D value in terms of mm. Make it fast. Tell me the D value in mm. When you are coming to the next class, you recall the all equations what you have in the strength of material and engineering mechanics. In engineering mechanics, you studied about the calculating the reactions at the supports, at the trusses and frames, I think. Okay, you recall the all whatever the relations are there, whatever the standards are there, you recall all the things while coming to the next class, because in next class whatever the things are there I'm going to explaining that all are very important, and you can expect the in examination as a direct 16 marks question. Whatever the problems I'm explaining the next classes regarding this design of shaft, that are totally directly 16 or long answer question 78.2. Answer you got D matter D value 78.2. Very good. 78.2. Okay. Is it right to all? Calculate the. I am expecting the from all people answers. Only one people giving continuously roll number 108, roll number 2, roll number 6. Three people have interacted to my class today, and rest of the peoples are sitting ideal. I don't know. Okay. Whenever you are coming to the next class, my suggestion is recall the all whatever the procedure is there to calculate the reactions at the supports and what type of loads. There are different types of loads are there. That is uniformly distributed load, uniformly varying load, okay, point loads, and hinge support, roller support, whatever the procedure is there to calculate the reactions that you need to recall, and whatever the equations are there for the bending moment. It means for simply supported beam, if point load is acting at centrally, that is WL by 4. Cantilever beam, W into L for the point load. For the cantilever beam, uniformly distributed load, what is the bending moment equation? W square by 2, I think. Okay. So equations, whatever you studied in the strength of material, you just recall the all relations. Without the strength of material, without engineering mechanics, you can't solve the this design of shaft, not this particular design of shaft. You want to get successful knowledge in the design of machine elements, you need the knowledge of the engineering mechanics, strength of material. Okay.
So you only once again recall those things in the class notes, sir, because recalling that and go, what will you say? Seeing that it is not able to understand, sir. Some concept we forgot. So if you show in the class some concepts before first 10 minutes,
Wait,
it would be good for us, no,
wait,
sir.
wait. Okay, I will show the only the equations. I can't explain the total procedure because
No, sir.
if I
Questions.
again start the procedure for the strength of material, you taken the last total semester. For the engineering mechanics, you taken the total 1 year, one total semester. If I again taught these two subjects again, you will complete the total semester for these two subjects only. When I am going to start complete this DME,
No, sir.
I
Means
can
the
explain the
important equations only, sir. Important equations that is useful in
equation.
DME subject.
Okay, whatever the equations are there, it means particular these equations are going to use in this DME. I can't say that because every equation and every formula, every procedure what you have in engineering mechanics and strength of material, each and everything is very important. Okay. So that is the reason I told one thing at the beginning of the starting of this subject, strength of material and this engineering mechanics, applied mechanics and material science subject knowledge. These are all very important, most important. You go recall that are all things I explained, I announced at the beginning of this subject. Okay. Anyhow, I will explain the some relations, whatever the going to use in this equation in next class. Okay. Don't worry about. But the thing is, go through the once again whatever the notes. I think you have you have written the notes as recorded in your notes as in previous classes. You just open that one and recall that one again, how to calculate the bending moment procedure. Okay, the procedure is very important here. So do you have any doubts regarding this problem? You can ask. Just wait, I'm taking today attendance is very less, 67. Why? What is the reason?